Okay, well, welcome back. It's time for another presentation, of course, and this one is aquatic biodiversity. So I thought I'd change up the settings a little bit again and do it right down by one of the famous New Jersey aquatic settings. So here we are, getting ready to start our day at the beach, or our lecture on aquatic biodiversity. All right. Yeah. All right, so this is a new one on me. Hopefully I'm getting myself in the picture here. But we start off with the aquatic biodiversity, starting to talk about coral reefs. Maybe in class we can talk about it. Some of you have probably been to a coral reef before, which is certainly fantastic. I myself have had that experience and certainly enjoyed it. So the coral reefs are beautiful, and they're in coastal areas, off the coast, where I'm at right now on the coast, but mostly in the tropical areas. And they have these tiny animals that give the coral the beautiful colors that they have. These tiny polyps, they're called, polyps. And these are algae, and they have a mutualistic relationship with the skeletons, the forming of the carbonate skeletons that I'll talk about in a little bit, the calcium carbonate shells, I'm sorry. And so this is the polyps, like I said, are the algae, and they have this mutualistic relationship. Right now, we are damaging these coral reefs that provide lots of economical services. Coral reefs are a huge area of biodiversity, and we know that's important for sustainability. They estimate that 1/4 to 1/3 of all the species live on the coral reefs, the aquatic species, the marine species. Another thing is it's a barrier to the coastline. It cuts down on the speeds of the water coming through. It's a barrier for that, and so it's pretty great that we have them here. But we are doing things that are damaging them. So for one thing, there's runoff from the local areas. That's a problem because we have built in these areas, so all of these protections are broken down a little bit. And another thing is the change in the temperature of the ocean. Now these polyps, these algae, can only form in certain temperatures. So as the temperatures are rising, they're unable to do that. And this results in something called coral bleaching. So you'll hear about coral bleaching where it really does look like a skeleton. There's no color to it, that beautiful color. And that degrades the whole setup there because the things that are living there are now compromised too because they need some of that stuff as well. So it's not just the color of it, there's a functionality to it. Another thing that we're doing because of the large volumes of CO2 in the air is we are adding to the acidification. What happens is I think I have some slides on this later on, so you'll see it again in detail, I believe. But yeah, there's a breakdown, there's a forming of a weak acid, the carbonic acid, and that prevents the calcium carbonate skeletons to form in the first place that the algae would be thriving on. All right, so aquatic systems. If you're talking about aquatic systems, first of all, we could say this. Saltwater-wise, that's about 71% of the Earth's surface, and 2% of the Earth's surface is freshwater. So we'll talk in more detail about these two systems here. And we know that the oceans are divided into 5. I'm standing right by the Atlantic Ocean right now, as you saw a little bit before. All right, so the things that are the factors that are going to include this are going to be the amount of salt water. That's going to be one of the things, and temperature is going to be another one. I said it before, but I want to say it again. The saltwater systems are called marine systems. So there's a little bit of verbiage for us. So the type of biodiversity that you're going to have is depending on the temperature. It's going to depend on the amount of dissolved oxygen that you have. The animals need that to breathe. The fish need the oxygen that's dissolved inside of the water to breathe, so that's going to be important. We'll talk later how the temperature and the dissolved oxygen content are related. So the availability of food is going to be another one of them. And also how much light and nutrients there are, because we need the light for photosynthesis and the nutrients to grow as well. All right, so those are the things that are going to give you the idea of the biodiversity that you're going to be having. All right, so again, saltwater, freshwater is how it's covered up there, and I already mentioned saltwater is about 71%, and the freshwater is about 2% of the water that's covering the surface of the earth. All right, so aquatic species can do some different things here. They can drift around, they can swim around, they can crawl, and they can cling. There are tiny, tiny things out there that you can barely see that are very important, and that's going to be the plankton. Now, the plankton are drifting around. They can't swim on their own, but the three types of plankton that we're going to talk about here are the phytoplankton. The phytoplanktons are the producers in the ocean. So they go through photosynthesis and they start the whole food chain working for the aquatic food chains. So they're very important. Also, half of the oxygen created on Earth comes from these phytoplankton. Recently, they've discovered these ultraplankton, which are tiny photosynthetic bacteria that also contributes to this, but that was found a little bit more recently than the phytoplankton. And the zooplankton are the secondary consumers. So they are things that maybe can swim around, they can make some movement. Or I shouldn't say that. Actually, they're drifters as well, like jellyfish and single-celled organisms, and zooplankton feed on the phytoplankton. Actually, now that I'm thinking about it, I'm thinking that some of the zooplankton can move around. I can picture the jellyfish moving around, right? All right. So the aquatic stuff is broken down into a bunch of characters, or a bunch of different categories. And nekton is a little bit of vocabulary for you. This is the fish and the turtles and the whales. These are strong swimmers that are out there in the ocean. The benthos are the bottom dwellers, like the oysters, clams, lobsters, the sea stars that we see. And these things these are very important filters in the aquatic system. They filter the water through. And then, like any ecosystem, you need the decomposers to break it all down and start the cycle back up again. All right, so so we've already talked about the factors here that are affecting it, so this is a repeat for you. But I'm going to add one more into here, and that's turbidity. So turbidity is how cloudy the water is, and that could be due to a variety of reasons, but it'll certainly affect photosynthesis, and there's other important reasons to think about turbidity. This is a way that turbidity is measured. This is one device that does it. This is a Secchi disc, invented by a person named Secchi, I suppose. But the idea is you drop it down until you can't see it anymore. And when you can't see it anymore, that gives you an idea of the turbidity. The sooner that happens, the more turbidity or cloudiness there is in the water. Okay, so these marine aquasystems are important. Well, first of all, people like sitting by them. There's a lot of recreation involved with this. People seem to like being by the ocean. I know I certainly do, and I'm glad to be here today. So that's important. There are biodiversity here that is no place else on the planet, of course, and you think about those aesthetic values, but it also keeps those food chains going. We're also, we eat a lot of seafood. Now, we're getting more into aquaculture now, but seafood is one of the last wild-caught food sources that we have. But we've industrialized how we go after that fish, that's for sure. So there's the ecosystem services of the food for us as well. And so the oceans are important for all those reasons. A lot of economics involved in the oceans. Right here down at the Jersey Shore, where I used to live, they're reliant on all of this stuff. Okay, so saltwater ecosystems are important for those reasons. And in these areas, there's three major zones that we could talk about, and there'll be a graphic for this in a little while. But first is the coastal zone, so that's right on the beach. So we're at the coast here, and the area that's right off the coast is also considered the coast. So that's the areas there. Then there's the open sea, and the other thing is the ocean bottom. So we've been mentioning these. These are the main the main areas there. All right. So here is a graphic, and I always tell you these things are important, but this gives you an idea of some of the things that we've talked about. Oh yeah, also moderating the climate. Water holds in. It takes a while for water to change temperature, so the climate is moderated at the shore, and that's a good thing to be talking about as well. in the summer, people like sitting by the ocean because the temperature is cooler. Remember that heat flows from hot to cold. So if the air temperature is hot and the ocean right here is cooler, because the air temperatures will go up to 100, but the ocean temperature never does, right? And so the warm air near the coast will go into the ocean. It'll warm up the ocean, but cool the air surrounding it. It's a more moderate climate. And in the winter, it's also true. The ocean temperature doesn't get to freezing, but the air temperature doesn't. So the ocean will give up some of its heat and to the local area. So it gives up its heat, and therefore, by the coast, it's a little bit warmer in the winter time than other areas would be. When I did live down at the beach, I know that the areas right near the beach got a lot less snow days. They would get rain events and all of that. All right, so that's the idea here. Here's a good idea to give you what kind of different things are out there with these zones that we're talking about. And yeah, so there you go. Now we're going to talk about these zones in a different way. We talked about the idea of what the zones were going to be, but there's other ways we can break this down, and this diagram does it for you as well. So the euphotic zone, which we'll talk about a little bit later in regards to water, is where the light is coming in. So there's the coastal zone, there's the open seas for you, the top layer is the euphotic zone, and then you've got this Bathel zone that gets Bathel zone, I believe it's pronounced, that gets a little bit less light, and then the abyssal zone that hardly gets any light at all. And it's very interesting how much we don't know about these areas yet, but there are certainly some interesting critters down there in that abyssal zone. All right. So now we're going to talk about estuaries. Estuaries are where the river meets the sea. So water flows downhill to the sea. When you're down at sea level, that's going to be the lowest point, and everything came down from the mountains, and that's the zone where the river and the sea meet each other. So this will be a mixture of areas where you'll have saltwater and freshwater at times together, and there are species that have adapted to be able to live in both of those at the same time, or comfortable in both. All right, and then there are the coastal wetlands. Wetlands are areas that are covered all of or most of the year in water. And these are marshes or mangrove forests, which I have a picture of in a little bit, all these things. But these are very important. Lots and lots of biodiversity, lots of net primary productivity. And also these coastal wetlands are another barrier to the storms when they come in. And what we've done is we've developed on these areas. So we've taken that vital area of the ecosystem out for our uses, which is very clever and amazing that we figured out how to do that, but detrimental is what it comes down to. Seagrass beds are in the shallow coastal areas, and they have lots of different species of grass and different plants growing in them, and that supports a lot of biodiversity as well. So that's right near the coastal area, these seagrass beds. Lots of nutrients involved in this stuff. There's a picture of a seagrass bed for you in the coastal areas. I saw that when I was fortunate enough to scuba dive by a coral reef. The grass out there was the first thing I saw, and it's just, in my opinion, beautiful to be out there in that and to be aware of it. High nutrient levels in these areas. These areas are also good for growing things, agriculture, lots of biodiversity there because of that. Humans have capitalized on that, but nature knew that as well, or that's what happened naturally as well. This is a picture of all the nutrients that are coming down toward the river. So a lot of them get dumped into these delta areas before they make it to the sea if we didn't develop over them. And again, it becomes fertile ground if we let it. All right, so here's another area like a marsh area, and this gives you an idea of those wetlands. I hope you've been out in some of these kind of things in your life. We have them pretty close by to where we live, and just beautiful areas. We don't have these around here. You need warmer climates for this, but these are mangrove forests that exist in that area. And these are, again, a big barrier toward, for keeping the storms down. So you've got these things in way of the winds and the waters that are coming in. They'll slow them down dramatically. But once we develop over them, again, we lose that ecosystem service, that benefit there. So now we have natural storms that are coming in naturally, but because of things that anthropogenically that humans have done, the results are a little bit more extreme. So that's the deal there. All right. Another thing I want to say about mangroves is that the shrimp harvesting has been one that people have taken the mangrove forests out. So shrimp harvesting is complicit or involved, I don't know if that's the right word, involved anyway with the idea of degradation of the mangrove forest. So that's something to be aware of. And this is just a picture to show you the biodiversity that's in these areas. Okay, so sometimes right near the shore there's rocky areas. Here where I'm at today, it's a sandy area, but this is called the intertidal zone, and this is the area between high and low tide. Right now it's low tide for me here. It's very calm water today, so there won't be as dramatic a difference between high tide and low tide, but there always is a difference, and these organisms have to be able to handle those changes in the intertidal zone. And also, so they're going to have different amount of salinity, that's the salt content, and different amount of moisture. Behind me, you might be able to see there is some development, but there's also, I don't know what you can see in the camera here, but there's also these dunes here. The dunes have been largely developed, but we're realizing more and more that these areas here offer a barrier. So they call these barriers to the next level back there to keep the storms from going. But again, we degrade that when we develop on them. So the organisms that live around there, they burrow into the sand, they tunnel into the sand, and that's how they live there in the intertidal zone. So I've been out to the Pacific Ocean too, and there it's a lot more rocky. So there's amazing, these tidal pools that come up, and the rocks and the things that were carved out by water through all that time, but there's a lot of biodiversity that's able to live in that area, and it's such an extreme environment. All right, and I did already mention the barrier beaches. So here's an idea that gives you, a little bit. That's more what you would picture, what I picture out in the Pacific there, up in the upper left-hand corner, those rocky shores. Although we have some of that on the East Coast too, just not as much here in New Jersey. So this is a graphic that gives you an idea of these animals that might have to tunnel into the sand to survive and all that other stuff. Okay. So wetlands, like I said, they are covered with water all of the year, or part of the year, or partially covered, but they have a vegetation that'll grow out of that water. And these are, animals and also plants that have adapted to that environment. Now, I've been talking so far about the coastal ones here, but these freshwater things that we're talking about, and they're at the coast as well, could be swamps or marshes or bogs, or they call them prairie potholes. So not only have I been talking about the ones at the shore, but inland there can be wetlands as well. So the ones close to the shore, the saltwater freshlands, and the freshwater wetlands can be near the shore, but I'm also talking about the inland ones. All right, so here I'm coming back to the coral reefs, and again, this time around I'm going to be talking about the ocean acidification in more detail. I mentioned it before, but here I'll give you some better things to go on. And this is the idea of the CO2 in the atmosphere. So just as there's dissolved oxygen in the water, there is also dissolved CO2. So this dissolved CO2 in the water is a natural thing, but there's so much more CO2 in the air right now that there's much more in the water as well. And because of that, that carbonate ion that's in the water that would be used to form the calcium carbonate skeleton of the coral reefs is now diverted into forming carbonic acid. So there's the carbonic acid. And this is a good chance too here to talk about a balanced chemical equation. So we talked about the idea that matter can't be created or destroyed. So in these reactions, it's a chemical reaction that takes two different things and turns them into carbonic acid. But here you have the CO2 reacting with the H2O to form the calcium carbonate. So that calcium carbonate, or that carbonate ion, is no longer available for making the the skeleton frame of the coral reef. So this is, we had talked about before about the coral bleaching. This is the idea that the coral won't form at all, and that's the idea of ocean acidification and how it's affecting the coral reefs. Okay, this is, and what I mentioned here is that if you notice, the subscript there tells you how many oxygens. So I think we're all aware of this, so this is a good one to talk about it. So CO2 has 1 calcium and 2 oxygens, and water, of course, has 2 hydrogens and 1 oxygen. So on the other side, you still have 2 hydrogens, 1 carbon, and 3 oxygen. And there's the calcium. There's the carbonic acid molecular structure, where in the middle you've got your carbon, and then you've got in white the 2 hydrogens, and the oxygens are the 3 red atoms that are listed there. All right, so back to the ocean again here, and the open sea and the open floor. Floor has a lot of stuff, so another word for you to remember is the pelagic zone, so that's the open sea, and then there is the euphotic zone, as I mentioned before, and that's the stuff that gets the light, and I mentioned the bathal zone and the abyssal zone too, and these are less and less light available as you go down. But the euphotic zone is where the photosynthesis can happen, and that's where the light is. In the euphotic zone, the nutrient levels are low, the dissolved oxygen levels are high, and in some places the upwelling bring these nutrients up, and that's very vital where you can have the real productivity there, where these upwellings that I had mentioned in other chapters happen, where remember, the nutrients fall due to gravity through the water. I have a helicopter passing over. We'll wait for the helicopter. But the nutrients, when things die or things get into the water that are nutrients, will fall because of gravity to the bottom, fall slower than they would as gravity pulls things through the air, and they call it the marine snow as it's drifting to the bottom. So all these nutrients are at the bottom, so when you get down to the abyssal zone, you're going to have high levels of nutrients. It's dark and it's cold, there's not very much dissolved oxygen, and that's where you have those bottom feeders, those filter feeders. But where these upwellings happen, now you've got the light and you've got the nutrients. So high levels of productivity where those happen. And as I mentioned before, they shift those areas. Those areas shift. All right. So in the middle zone, the bathal zone, it's dimly lit. There's some zooplankton and smaller fishes in there. And we've already talked about the abyssal zone a little bit here too again. The net primary productivity in the ocean and the open sea is low, but there's a high volume of it. It's low except where the upwellings are. But there's so much of it. The open sea covers so much area that there's a lot of productivity, but the net primary productivity is low, but they just have it in volume here. All right, so here's an idea of the upwelling and the kind of life that you can get and a little bit of the water. So here's a graphic that gives you an idea of that. We're finding out more and more about the ocean always. Like I said, we don't know all that much about it, considering we're right here near it. But we're finding out more and more all the time. And there have been studies recently that are finding there's life forms out there that we had no idea about at all. And most of these that we're finding out that we didn't have any clue about are microscopic, these microbes. And so that's, then they contain these proteins, and there's things that we just don't know what they're really used for out there yet, but we're finding they exist and we didn't know it. So there's a higher diversity even than we know in the ocean, and we're finding out more and more about it all the time. It's just fascinating how the technology is changing, so we're able to figure out a lot more things, and that's where we're at in humanity right now, right? All right, so we are still learning about the ocean's biodiversity, and that was what I was just talking to you about. All right, so how have the humans affected this? Well, for one thing, we've used the ocean as a garbage dump. We thought it was endless, so we just dump everything into it and figure it'll go away. Right now in 2022, a big issue is the garbage patches that are out there, where all these plastics, single-use plastics. Also amazing that humans figured out how to do it, but they just last forever. And they're also based on fossil fuels, so there's nothing sustainable about this, and they create pollution that can't be broken down. So that's one way that we've done it. I've already talked about the climate change and the ocean acidification, so that's another one. Another big thing that we've done, I've mentioned a little bit, but I'll mention it before, is we have developed at the coast. So we have created problems by all the developing that we're doing. So it's not just that we dump things, but there's runoff from the areas that are right around the ocean, areas that we've developed, and they bring pollutants into there. And then we bring these ships out there, and the ships are polluting things. And we've moved things around in the ocean, so we've created invasive species that are happening out there where they wouldn't have before. We're bringing things from one area to another area as we move these ships through there. Another big thing that we've done is we've overfished. So we've taken the fish that are out there and we are removing them faster than they can replenish themselves. And this is where we're at right now. I'm going to talk a little bit more about one of the things that's listed in this graphic here, the algae growth. But yeah, these are the things that we have done, and we're going to go into all of these as the course progresses. Okay, so back to freshwater systems now. Lots of things with freshwater systems too. So these are the things that we like at them. They also can moderate the climate. We have huge bodies of freshwater. They're involved with all these things that the marine systems are involved with too. And they're also used for transporting things around. There's an economic things that come in, but we're also reliant on this fresh water for our drinking and for irrigating our crops. You can't do either of those things with salt water. Just as we do with the ocean, there's recreation and employment as well. But another thing that these freshwater systems and rivers are what we're talking about here is that they have been dammed, and from that they have been able to give us electricity, which has been a huge game changer for the human race and also comes at an environmental cost, as an environmental degradation. You know, as I'm talking about that, I just read an article this morning before I started making this video, so earlier this morning, about some of the dams out on the Colorado River that are not going to be able to deliver that water or that electricity for very much longer. It's a crucial point out there right now in 2022. All right, so these are the reasons that the freshwater ecosystems are important and we should care about them. Okay, so we could talk about lakes and ponds and wetlands, and another fancy word for that is lentic. This is surface water that's standing, flowing, like your rivers and your streams and your brooks and all those kind of things that are so enjoyable to sit by, or the lotic, so we have another fancy word there to be talking about. And if we're talking about the lakes, they have zones as well, just like the ocean will. So the littoral zone is the stuff near the banks where you can get plants growing. There's a lot of biodiversity, a lot of animals live there. That's where your frogs and your turtles are. Some fish live in that area. That's right along the banks of the area. The limnetic zone is going to be an area where there's still sunlight, and that's where a lot of the photosynthesis is going on. You're going to find some larger fish out there. And then there's the profundal zone, which is deeper water. There's no chance for photosynthesis out there. It's too dark for that. Not a lot of oxygen, although there are some fish that are adapted to that area. And then the benthic zone is the bottom, and this is where you'll find, like the marine zones, the decomposers and the detritus feeders and things that are going to break things down. And this is, again, mostly like the marine zone, I should say, where there's a lot of dead things that have added nutrients to that area. So there are nutrients down there. And here's a graphic that gives you an idea of these different zones, help you remember that area and give you an idea of what's living out there. Okay. All right. So The nutrients for the lakes aren't evenly distributed. Some of them have lots of nutrients and some of them don't have very many nutrients at all. Oligotrophic lakes are ones that don't have a high level of nutrients. These are going to be crystal clear waters. When I was a kid, we used to have a place called Blue Waters, we called it. And what it was they had been digging. There had been sand. They were digging for sand to make bricks, and they hit water. So this water came out, but it didn't have a lot of nutrients. It was just from underground. It was deep underground. So there weren't a lot of these nutrients that got into the water, and because of that it was blue. So oligotrophic are lakes that are crystal clear. And eutrophic are ones that have a lot of nutrients. They are a little more cloudy, a little more turbidity. Now that we got that word, we can throw it around. And that would be more like lakes that have been around for a while and have a lot of things growing in them. Cultural eutrophication is where humans are adding nutrients in at high volumes that have detrimental results to these lakes. And you've probably seen this where there's a huge amount of algae on the top of the water. That's kind of a common thing in lakes around here because of the nutrients that we've added. So here's an oligotrophic lake, very nice to be sitting by. And here is one that has more nutrients in it, more eutrophic. So it gives you an idea of that. Now, the cultural eutrophication is something I get back to because there's the slide that goes along with it a little bit later. But I want to just give you the heads up now that we're going to go through the details of the damage and the causes from cultural eutrophication coming up pretty soon. All right, the streams and the rivers move large volumes of water. This is all downhill, moved by gravity, as we can imagine and have mentioned before. So here's your source zone where the water comes from. This can come from, lots of water that's going to be falling there is going to come down, but it also comes from waters that are water that's held in ice, and then it's let go in abundance when the ice melts seasonally. So that's the source zone there. And when you're talking about the source zone, you're talking about where the water comes from, of course, like I said, and you're talking about waters that are going to be high in dissolved oxygen, and they are going to be areas there that are, like I said, high in dissolved oxygen, and they're going to start flowing from there down to the transition zones. Transition zones is the middle area, right? So in the middle area, you have a little bit of floodplains going on, but down at the bottom there is where you have the delta in the floodplain zone. And the deltas are these real areas that are really, really good for growing things, and lots of growth comes out down there. Very productive, as I mentioned before. And then you go out to the ocean. All right, so lots of good things going on in these different areas that are important for us. So we've now talked about them a little bit. All right, so in this source zone, like I said, there's a lot of dissolved oxygen. There's nutrients there too. They've been there hasn't been a lot of flow through there, so there's nutrients in there. There's shallow water mostly. It's cold. It's clear. You can see where the ice is, so that's going to be the deal there. In the transition zone, the water can get a little deeper. You'll have streams starting to form. They're a little bit more turbidity and less dissolved oxygen at those points. And then in the floodplain zones, like I said, they're going to be more nutrients are going to be down there, and that way you can have lots of growth that's going to go on. Not as much dissolved oxygen, and the temperatures are a little bit higher too. And all these things should make a little bit of sense, I suppose. All right, so we've talked about the source zone, we've talked about the transition zone, and we have talked about the floodplain zone. Okay, so these, like I mentioned before, vital sponges for you here. So these inland water lands are going to cut down on your flooding because they're going to absorb this stuff if we let it. And this is a picture of it. You can picture these areas here just covered in water. And what have we done with this? Well, we have done lots of things that have done this, as I mentioned before. We have developed on them. We have, we have polluted them. We have done all these different things that we've talked about before that are going to be detrimental. And because of this, because of the idea, we have subsidence. Now, subsidence is where you're getting a sinking of the land. So because we're taking out some of this stuff here, we are getting ourselves into areas that are sinking down because of what we're taking out of them. So we're taking out of these things, and that's causing this sinking. And mostly it's because of the sediments. So, like I said, the sediments are going and being released all the way through. But what we've done is built these dams and these water projects. And this has been great for humanity in the short term, or for many reasons, I should say. But it does cut down on the amount of nutrients are in there. Then there's less nutrient in the ground, and the ground actually starts sinking. So that becomes a problem. I already mentioned the idea that a couple of times over about how we are, they also cut down on the storms because they're doing this. But we have done all kinds of things to disrupt this. Okay, so we also rely on underground water aquifers, and these freshwater areas are good for recharging those, and we've taken that ability away from them. We have lots of habitats that are in there. We fish in these areas. There are products that come out of there and the fishing that we like. This is a form of recreation, so is kayaking and boating, and by developing on these freshwater systems, we are taking that away. All right, so I went into the subsidence in detail and all of that stuff. I do want to talk again about the idea of the cultural eutrophication. So with the cultural eutrophication, there's some concepts that you should be aware of and how this thing plays out. So what happens is, and this is largely from fertilizer, we have figured out that plants need nitrates and phosphates. So you're going to be needing to name names when it comes to cultural eutrophication. And nitrates and phosphates are a couple of those names. So we have put these nitrates and phosphates into the fertilizer. That runs into these areas, and when they run into these freshwater areas, those supply nutrients for bacteria to grow. So the bacteria starts to grow, and when the bacteria starts to grow, a couple of things happen. One thing is it immediately is going to block out the photosynthesis. So now the light can't come through, and that's going to cut down on the productivity. Another thing happens is as the algae dies off, bacteria goes after it, and that bacteria can now be supported at a high level, and because of that, the amount of dissolved oxygen. Remember, the plants need the dissolved oxygen to breathe, and now the dissolved oxygen is compromised as well because the bacteria eating the algae as it dies cuts down on the dissolved oxygen, and that's vital for the life in there. So that becomes problematic, of course. Okay, so I guess that's the nuts and bolts of it. Pollution, sewage runoff also add to it. But it's really important to understand now about the nitrates and phosphates that are being added through the fertilizers. That's the main thing for cultural eutrophication, and it's a good thing to know about the nutrients that are necessary for the plants to grow also. So that is the end of this video. We'll turn around and show you the Jersey Shore behind us one more time. And look forward to seeing you back in class. All right. Bye for now.